Hey class, Miss Anderson here. Today we're going to do some review for Unit 5. So I'm going to go over each of the sections and questions that you can expect to see. Just have a overall view of what to expect for the Unit 5 assessment. So first we started Unit 5.1 with finding all of the zeros of a polynomial equation. So my first example is a cubic equation. And I haven't been given any roots, so you're going to have to plug this into a graphing calculator to find one of the real roots. And so I chose Desmos because that's most user friendly, and I have it plugged in already just to save some time. So you can see I have that 3x cubed, 9x squared plus 4x plus 12, and I'm looking at this function. And I see it crosses the x-axis one time, which means I'm going to have one real root. This has a cubic function, so there's going to be 3 roots total. I have one x-intercept, so I have one real root. That means my other 2 roots are going to be imaginary. So I know that based off my graph, x equals -3. So then I'm going to take that and I'm going to plug it in using synthetic substitution and do some polynomial division here, some synthetic division. So I'm going to plug in -3, take the coefficients from my polynomial, 3, 9, 4, and 12. I have all of the coefficients, no zeros are needed here. And then do synthetic division or drop mama. So drop it down, and then mama stands for multiply. And add. So -3 times 3 is -9, and then you add vertically. 9 plus -9 is 0. Then you repeat. -3 times 0 is 0. 4 plus 0 is 4. -3 times 4 is -12. 12 plus -12 is 0. Since this was an x-intercept, it met the graph at -3, 0. When you plug in -3 for x, you should get 0 for y. You should get no remainder. So that's another way to check that that is in fact a solution. So we're looking for the x's that make the equation equal to 0. So now we have, we had an x to the third, and we divided by 1x, and so we're down to an x squared, and then this would be an x, and this would be your constant term. So now you can write that out as 3x squared plus 4 equals 0. And then we're going to go ahead and finish solving for x. So if I take 3x squared plus 4 equals 0, you could either do the quadratic formula when a is equal to 3, b is equal to 0, and c is equal to 4, and then you could use the quadratic formula. But since b is equal to 0, you can actually solve this one by square roots. So if you have 3x squared plus 4, you can just subtract 4, isolate the part that's being squared, so you get -4, divide by 3, get x squared equals -4 thirds, and then take the square root of both sides. So when you take the square root of a fraction, you can actually split this up. You can take the square root of the top over the square root of the bottom separately. Now the square root of -4 is going to be plus or minus 2i, and the square root of -3 is irrational, so we would leave that. And then that would be our other 2 answers. So x equals -3 and x equals plus or minus 2i over the square root of 3. And then you could go one step further and rationalize it, so multiplying by the square root of 3 to get the radical out of the denominator. So this could also be written as 2i square roots of 3, and then square root of 3 times the square root of 3 is the square root of 9, so over 3. So 2i square roots of 3 over 3. Both of these are correct answers. This one's just in rationalized form, so either one would be fine. Okay, we're going to do that one more time. This time I have a quartic function, so it's a 2x to the 4th. And I have to start the same way. We go ahead and plug that into Desmos, and we look for some solutions. And so I have turned that one off, put this one on. I have that one typed in as well. So we can tell this is a quartic function, and it looks like I have 2 x-intercepts. So that means I have 2 real solutions. There should be a total of 4 roots, My first two roots are going to be the x-intercepts right here, x equals -2 and x equals 1.5. So I'm going to use those to help me finish solving for the other roots, which are going to be imaginary again since I didn't have any other x-intercepts. So I'm going to start with -2. You could pick 1.5 as well. We're going to do synthetic division again. I have x to the fourth, x cubed, x squared, x, and a constant. So I don't need to add any zeros here, but watch for that. So listing the coefficients then in order. Then do drop mama, drop it down, multiply, add, multiply, add, multiply. So I'm multiplying this way, adding vertically, multiply, oops. Yep, made a mistake there. And then I knew that this was supposed to be 0, so I caught my mistake. Okay, so since I went from an x to the fourth, this would be x 2x cubed minus 3x plus 8, or 3x squared plus 8x minus 12. Now, you might be able to do factor by grouping here and then solve from there. Or because I have another real root, I can substitute that in synthetically and use these coefficients, the ones that I just got, and divide one more time. So drop it down, multiply by 1.5, which would be 3. It's 0 times 1.5 is 0. 8 plus 0 is 8. And then 8 times 1.5 would be 12. -12 plus 12 is 0. So then I end up with, so now this time I went from cubic, so this would be quadratic, 2x squared, 0 x's plus 8 is my constant. And then I can solve that one, 2x squared plus 8 equals 0. You could use the quadratic formula again, but since you're missing that b term, b is 0, there are no x values here, you can solve by square roots again. So subtract 8, divide by 2, and then take the square root of both sides. You get 2 answers when you take the square root because there's 2 possibilities for x here that would make -4, and it would be 2i since it's the square root of -4. So those are 2 answers, and then we had -2, and then we had 1.5 as our other 2 answers. And so remember, you could have took this and done factor by grouping at this step too, and I think it would have worked okay. You would have done, I think it's possible, you'd do 2x cubed minus 3x squared, 8x minus 12. This row has an x squared in common. This one has a 2x, x squared times -3, and x times 8. Oh wait, that would have been 4. And then you would have factored that to be 2x minus 3 and x squared plus 4. And then set each one equal to 0, 2x minus 3 equals 0. That would have given you the 3/2. Add 3 divided by 2. That's our answer of 1.5 that we got. And then this one is the same thing that we did over here. X squared would equal -4, and we got the plus or minus 2i. So it would be possible to factor by grouping at this step, but you could do synthetic division one more time and break it down to a quadratic. So you have some options, but know that the degree will tell you how many answers you should end up with, and so we want to make sure that that matches when you're done. All right, more on that in 5.1. Then we talked about analyzing graphs and end behavior. So we looked at estimating x-intercepts and maximum, minimum values. So when we're looking for x-intercepts, we want to list them as ordered pairs like x, y, and we're just going to estimate these values. This graph is counting by twos, and so my far left x-intercept would be at like negative 4.20, and then I had another x-intercept right here, which looks like it's really close to like 1, 0, because it's counting by twos. This one looks like it's really close to 4.20, and then we have one right here, 2, 4, 6, 8, maybe at 9.20. So just doing your best to estimate those. There's 4 x-intercepts. Then we have maximum and minimum values. We have a maximum value. It won't let me change my pen color or switch to anything else, so I apologize for that. We have a maximum value right here, top of a hill. We're looking at what corresponding y value goes along with that local maximum, and I would estimate like maybe 1.4. Y equals 1.4. Then we have 2 minimum values. Right here is 1, and then right here is 1. So minimum values are the bottom of the hills. These are -2, -4, maybe -4.4 on the left, and then -4 on the right. And so we want to list all of them. And then since there is 1, 2, 3, like a max, 1 max and 2 mins, that means that there was 3 turns. So there was 3 turns here, which means my lowest possible degree is 4, because we have the theorem that says if you have a degree of n, then the max number of turns is n minus 1, 1 less than the degree. So if you know that there are 3 turns, then there are possible lowest degree would be possible degree of 4. And you also know that even functions go this open up or down, so this would match a degree of 4 function. Okay, you'll also be expected to be able to find these values from using a graphing calculator. So again, looking at Desmos, and I have this one typed in as well right here. And so Desmos is really nice because it can actually give you all of the values. And so I'm going to go ahead and just sketch that quick. And then it looks like we have 1 x-intercept. If you touch onto the function, it will highlight all of the key points, and you'll be able to touch it, and it'll light up to what it is. And we're going to ask for the tenths place, so rounding to like 1.60. There's only 1 x-intercept there. We got 1 maximum value, and remember, I'm looking for the y coordinate. And then we have 1 minimum value, again looking at the y coordinate. Whoops, probably round that to 2.6. And then that would mean 1 max, 1 min, 2 turns, and the lowest possible degree is 3. And you know that too because you typed it in. So, all right. We should be done with Desmos for a little bit. Then you're going to see questions like this that are going to ask you to think about polynomials and what you know about them. So what is the degree of the polynomial and how many solutions would it have? This one is, the degree is the highest exponent, so this is 5th degree. And then the fundamental theorem of algebra says that the degree tells you how many solutions it will have. So it will have 5 solutions. I'm not asking for how many real or imaginary. I'm not wanting you to find them. I'm just asking, based on the degree, how many solutions will it have? Okay? And then this one kind of goes along with it. So the degree matches the number of solutions, and then what's the maximum number of turning points is 1 less than the degree. So if the degree is 5th degree, it will have less than or equal to 4 turns. That would be the maximum number of turns would be 4. Next one, if you have a 4th degree polynomial and are given 1 imaginary root, what is the maximum number of real roots? So this is where we have to remember that when we solve for imaginary roots, by definition, you get imaginary numbers by taking the square root of a negative number. And whenever you take the square root, you always have the two answers, plus or minus. And so imaginary roots always come in pairs because of the way that they are derived. And so if you're given one imaginary root, that actually means that you have two imaginary solutions. You cannot have an odd number of imaginary roots. So if you have two imaginary solutions and it was a degree of 4, so you have 4 total solutions, that leaves me with a max of 2 real solutions. And that would actually be my only possibility here, because you could not have 3 imaginary solutions and 1 real, because imaginary solutions are always going to be an even amount. They have to come in pairs. Sketch a polynomial that has 5 roots, 2 of which are real, and that has the following end behavior. So I want you to sketch a degree of 5, so x to the 5th, which means you can have up to 4 terms. And you have 2 real roots, which means you have 2 real roots, means that you have 2 x-intercepts and no other x-intercepts. And then we have the following end behavior. So as x is going to the right, or as x values are increasing, so x's get bigger to the right, the function is going to be decreasing. It's going to negative infinity. So on the right, we're going down. And then as x is going to negative infinity, that's the left. That means as x is decreasing, as you're picking smaller x values, your function is going to positive infinity, which means that the function is increasing or going up on the left side. So let's see what we can come up with here. So on the right, we're going down, and on the left, we're going up. So going down, and then on the left we're going to be going up. So let's see, just trying to think how I could draw this so that it only has 2 x-intercepts. So I think I want to do nope, that's not gonna work. Okay, so going to have to 2, 3, 4. How could I make this cross twice? Let's see. Maybe like that. So 1, 2. And you could have more turns, but it got a little tricky there. So I don't know if I could make it work otherwise. Could have up to 4 turns. Since it's a degree of 5, I know I'm going to have end behavior that's going to be going different directions. Describe the end behavior of this graph and how many real solutions does it have? And what would be the lowest possible degree? Okay, so describe the end behavior first would be like on the right, or as x's are getting bigger over here, as x's are getting bigger, my function is also getting bigger. So as x is getting bigger, my function's getting bigger. So I would write as f of x, as x is getting bigger, my function's getting bigger. I wish it would let me use my highlighter, but... And then as x is getting smaller, this side, my function is going up again. So as x is getting smaller, decreasing, my function is still increasing. So that would be my end behavior. So we're going to positive infinity on both sides of this graph. How many real solutions does it have? It has 1, 2 x-intercepts, so it has 2 real solutions. And then what is the lowest possible degree? Since it has 1, 2, 3 turns, or 1, 2, 3 local max and minimum values, 2 minimums and 1 maximum, it has 3 turns, which means the lowest possible degree would be 4th degree. and it would have to be an even degree based off the end behavior. It could be a degree of 6, it could be a degree of 8, but the lowest degree it could be is 4, which means it couldn't be x squared because it has too many terms, and x squared would only have to be able to have one term. Okay. And then we got into graphing. There's 2 examples, and I did do some of the work ahead of time just to save some time in the video. So the first thing you want to look at when you're graphing is to figure out the degree. So we're in factored form, but I want you to consider if you multiply this out, what would be the exponent for your leading coefficient? So you would have an x times an x times an x, which means you would end up with an x cubed. So this is a 3rd degree. And then our a value is negative 1/4, which means that it's an odd function because the exponent is odd, and our leading coefficient is negative, so it's going to be a decreasing function. So which means from left to right, the values are going to go from like positive infinity to negative infinity. The function is going to start really high and then decrease as you move from left to right. So that means that on the right side, you're going to be going to negative infinity, and on the left, you're going to be starting up here. So it's going to be a decreasing function. So starting and then decreasing. So that's what our end behavior is going to look like there. Then we take our factors, and we solve them for x. So x minus 4 equals 0, you would get x equals 4. Oops. So 4, 0 would be 1x intercept. And then we would have negative 3 and negative 1 as our other x-intercepts. And I'm going to go ahead and put those on my graph. And then we want to make a table of values, and we're going to choose some points in between. So I have my negative 3, negative 1, and 4 in red. Those are my x-intercepts. And then I picked x to the left of negative 3, so I chose negative 4. Then I used my function that I was given, and I replaced all of the x's with negative 4, and I used a calculator to help me evaluate it, and I got 6. Then I did a point between negative 3 and negative 1. I picked negative 2. I plugged negative 2 in for x, evaluated that, I got negative 1.5. Then I have my x-intercept, and then I did between negative 1 and positive 5, I picked, between negative 1 and 4, I picked 0. Plug 0 in, I got 3. Then greater than 4, I picked 5. Plugged 5 in, I got negative 12. So then once you have all your points, go ahead and graph those. So negative 4, 6. Negative 3, 0 is already graphed. Negative 2, negative 1.5. Negative 1, 0 is graphed. 0, 3. 4, 0. And then 5, negative 12. Okay. And then thinking about the end behavior, so once I connect these points, then looking back to my end behavior and remembering that since it's an odd degree that's negative, it's going to start really high and then continue to decrease, which means I can finish off my graph. I know it'll be going to positive infinity on the left, and it will continue to negative infinity on the right. And so that is what my graph would look like. And it also is degree of 3, so I'm pretty confident that it's drawn correctly because it has 2 turns. So that was graphing in factored form, which was from 5.3. Then we did graphing in standard form as well, which is multiplied out version, and that was in 5.4. It started similarly, so we looked at the degree. This one's easier to find because you just look at the highest exponent, so it's 4th degree. And then you look at the leading coefficient, which in this case would be 1. So this is an even function with a positive coefficient, and so you would have end behavior something like this. So even functions either open up or down. And so that means that our function's going to be decreasing, then increasing again, and it's going to end up looking similar to that. And so we're going to be going to positive infinity on both. Since it's a fourth degree, it can have a max number of 3 turns. Then, since it does go to infinity on the ends, we want to know what happens in the middle so we can get a sketch of the graph. And so we try to stick close to 0 because the bigger you pick on the ends, the bigger the output's going to be. So we pick -2 to 2 every time. I've already done the math just to save some time here. So I have my function, and you can evaluate these values 2 ways. So if you get f of x and you just plug in, if I wanted to find the value for -2, I plugged in -2 for x, and then I solved this. Now, if you do it this way, you would have to probably use a calculator because it's a bit challenging to do this math in your head. And that would be fine, but I got 32. And you can also do it with synthetic division or synthetic substitution. So I took my coefficients. I did have to add in a 0 for the x squared term, and then I did drop mama, and I got 32. And then I was able to do this without a calculator. So I did that again for -1, and it's, in my opinion, it is just easy. It almost takes me longer to type this into the calculator than it did for me to do this, but up to you. Either way, get your 5 points by replacing all of the x's in the equation and then solving for y, and then we're going to graph it. So -232 is going to be way off my graph, but I know it's going to positive infinity, so I'm okay with just knowing that that's going to continue to be going up there. Then -1, 1, 0, 2, 1, 5, and then 2, 4. And so far, if I graph these from left to right, I would end off right here. And this is where it's very important to remember, like, what was your end behavior? Because it might be tempting to continue to draw the line this way. But we have to remember that we had an even function, and it was supposed to look like this, which means it has to turn back around and come back up. And so using that end behavior to determine how the function is going to look on the ends is an important part of graphing. You do not want to just continue following that down. And that's it. Okay, I hope this was helpful.